Welcome to this Brainline exclusive video in which I will be helping you to solve electric circuits. Always ensure that you know all the theory from the cheat sheet, know the definitions, know the terminology, and then also the formulas. Make sure that you know what the different resistance values mean, what the different potential difference values mean, and how resistors are related to each other when connected either in series or in parallel. Once you know all the theory, it's time to get ready to learn to analyze any circuit. Before looking at all the sub-questions asked, look at the circuit itself, study it, and see what information has actually been given and what calculations you can do with that information. Always start off by looking whether the EMF has possibly been given or whether there is a reading on the voltmeter across the cells while a switch is open. Next, see whether there is perhaps a value for the external potential difference, in other words, the voltmeter reading across the cells, but once the switch has been closed. There will usually be resistors in parallel. Ensure that you can calculate R parallel and remember to do the inversion at the end of your calculation. Next, see whether you can find R external, in other words, by the addition of the R parallel and then R series for all the resistors in series. See whether the total current has perhaps been given. It might have been given as a reading on an ammeter which has been placed in the main series circuit. The next formula is very important, in which we go and use the EMF. I will show you in detail how to apply that. If at any time you get stuck, try to find a resistor where you have two values. Remember that the formulas all have three variables in, so if you have two, you will always be able to find the third. This formula for the EMF is to be found on the data sheet. Remember that the EMF can be replaced in general by a word like V total. It is the total potential difference in the whole circuit. The I does not have a subscript, but you of course can add the subscript total to it. It will help you to remember that that is the value of the current in the series circuit. Then there is a capital R and a small r. The capital R refers to all the external resistors, resistance added together, and the small r refers to the internal resistance. Of course, it would be possible to multiply the I, which is outside the brackets, into the brackets. In other words, to take the I and multiply it by the green R and then by the orange R. If we were to do that, we would have the I total, which would be multiplied by each of the R's. In the first step, by the external, and in the last step, by the internal resistance. Now, of course, we've already studied Ohm's law. So in Ohm's law, we know that the resistance equals the potential difference across the resistor divided by the current flowing through the resistor. If I were to multiply the I across to the R, we would therefore have the formula V equals I times R. It's important to remember that a specific voltage is always related to a specific resistor and its resistance. In other words, if you're working with a specific resistor, ensure that you work with the voltage which matches with it. And the same, if you're working with a specific voltage, ensure that you know which resistor you are working with and have to use. Now, if I use the formula that I've shown you there, it means that I total times R external will in other words, relate to a specific voltage, the same on that side. And here we would then be able to say this is equal to V external. Remember that the V and the R match. And this term would be equal to V internal. V and R are matching. The same way, we would here have been able to replace V total with I total multiplied by R total again. In other words, the total voltage, or the EMF, is equal to the external plus the internal voltage. Now I can do exactly the same by just looking at the R's. In other words, I would be able to take the R's out in this specific example, and thereby by using the R's, I would see that R total would be equal to R external plus R internal. So we've got a calculation which we could be able to do, where we had V total is V external plus internal. We've got R total is R external plus internal. And then, of course, there are these three formulas which we will be able to work with. In other words, we can work with R total is V over I total. R external is V over I total, or R internal is V over I total. So we effectively have an internal resistance formula, an external resistance formula, as well as then a total resistance formula. And these we're going to use very well in solving any circuit that we're going to look at. To show you how I analyze a circuit, I will be using a question from a DBE National Senior Certificate Grade 12 paper for higher grade 2004. Although this is quite an old question, it's really a good one. It shows us a lot of the principles we need to apply. Now, the first thing I would like to do is just to mention here that in this original question paper, there was slightly more info, and it was actually stated that the EMF for the circuit was 24 volt. It obviously then also stated that the ammeter and the connecting wires had negligible resistance, and we were told that when switch S was closed, the reading on the voltmeter V1 dropped to 20 volt and voltmeter 2 registered 4 volt. The first thing that we do is I always write down the formula in the way that it was given, but seeing as I'm doing this on my question paper, it wouldn't be that bad if I didn't, but just to be sure, I'm going to say EMF equals I, and then those are the total values. That will be multiplied then by the external resistance, R external, and added to that, R internal. I'm going to multiply that out for myself, and I'm therefore going to end up by saying that the total current multiplied by the total resistance, because that would have been the EMF, equals the total current multiplied by the external resistance, and added to that the total current multiplied by the internal resistance. In other words, this was V internal, this was V external, and this was the EMF, or V total. Now the first thing I can do is I can write down the value for the EMF because it was given. So this value was 24, and on my question paper I would be doing this as a rough work, and I would indicate the 24. The next thing that I see is that they have given me the reading on the voltmeter. That would have been the same voltmeter, but for the EMF it would have meant that the switch had to be open, no current would have been allowed to flow, and now they have told us that with the switch closed, this voltmeter reads 20 volts. In other words, what they've actually done is they have given us the value for V external. Now, if I put that equals back, the plus back immediately we can see that we have just found the value for V internal. V internal would therefore have been 24 minus 20 and therefore 4 volts. So there's the first thing that I have found. At this stage, I can see that there is a resistor in series and there are some resistors in parallel. I can see that I have all the values, so perhaps that would be the next step I would have to take. I mentioned that once you have done this, I would like you to find R parallel. What is important for you here is to then also see that we are looking at two resistors which are in series in a parallel branch. Let's just quickly consider the current flow. We would have a flow of current and then a split where some of the current would flow through the 16 ohm and the rest would have to flow through both the 4 and the 4. In other words, the value for the total resistance in the outermost branch would actually have been 8 ohms. I would therefore be able to do the calculation for R parallel by saying 1 over R parallel equals, firstly, the 1 over 16, and then the next part would actually be the 1 over, and it would have been the 4 plus 4, in other words, 8. We find the lowest common denominator, which is 16, so this remains 1 over 16, and that is then 2 over 16. In other words, the inverse of R parallel is 3 over 16, meaning that R parallel would be 16 over 3, which would end up being 5,33, always work to 2 decimal places, ohms. Well, the next thing that I can try to do is to see if perhaps I have a resistor for which I have two values, and indeed I do. We have this 4 ohm resistor and we have the voltmeter which matches it. In other words, I would be able to calculate for this specific resistor R equal to V over I, where I would therefore say that the resistance was 4, the potential difference is 4, I don't know the current, and by changing the subject of the equation, the current would equal 1 ampere. In other words, for this whole part, the current flowing through here would equal 1 ampere. Remember that these two resistors act together and therefore add up to the 8 ohms. That's what we used to calculate the parallel resistance earlier. And if I compare this 8 ohm to the 16 ohm, I can see that I would be able to calculate by a ratio what the current flowing through the 16 ohm would be. Remember that because we are working in a parallel network, we of course know that the reading for a voltmeter like this 4 volt, and that is a 4 ohm and a 4 ohm, we would have another 4 volt combined over here. In other words, the reading for the parallel network would be 8 volt. It would also, of course, mean that there would be 8 volt on this side. Now, there are one of two ways to calculate the current which flows through this 16 ohm resistor. We could either again use R equals V over I. Again, the 8, which we've just found, is therefore equal to, we know the resistance 16, we don't know the current, and I could therefore get the current to equal 0,5 ampere. Of course, there's another way to do this. Although we now know that this is 0,5 ampere, we could have, of course, done this by ratio. As we were working in a parallel network, we knew that the V was constant, and we therefore knew that the resistance and the current would be inversely proportional to each other. In other words, where we had the 8 ohm resistor and the 16, this had double the resistance, half the current, and we therefore would have expected exactly half of that 1 ampere. Of course, once we've calculated this, there's a lot that we can do, because we now know that the current which was flowing through the two different parts is firstly here 1 ampere and then 0,5. It would therefore mean that I total would have been the current flowing through each of the branches 0,5 plus 1, in other words a total of 1,5 ampere. Now this 1,5 ampere is therefore the total everywhere in the circuit. In other words, the 1,5 can be substituted into each of those. This means that if I were to look at these as the formulas that I showed earlier, it would mean that in this formula I could calculate R total. Using this one, I could calculate R external as we have those values, and the same on this side. We could actually calculate R internal. Good luck with solving electric circuits. I trust that using the steps which I have shown you and showing you how to analyze a circuit diagram before reading through each of the sub-questions, you will be able to solve the questions set to you in the exams. Good luck to all of you.